Hello everyone. In this video I continue doing a final exam review. I'm gonna solve questions number 16, 17, 18, 19 and 20. So I'm gonna solve 5 more questions in this video. Okay, question 16. 3 graphs are given below. For each, choose its equation from the following. Okay. Alright, let's look at the first graph. This is the first graph. If you look at the shape of it, it looks like the tangent x, right? And tangent 0 is sine 0 over cosine 0. Sine 0 is 0, cosine 0 is 1, so 0 over 1 is 0. So yes, this also satisfies that. So this guy is tangent x. Let's go to the next one. Okay. If you try to fill, the graph like that, this is the graph of cosine, right? Actually, even the graph of 2 cosine x. But this is not the graph of 2 cosine, but you need to flip cosine. And if you flip cosine, you will get 1 over cosine, which is secant, right? So it is 2 secant x. And this one, okay. All right, so what does the graph look like? First of all, if you look at here, when x is 0, right, the function is giving 1. It is not secant, it's not cosecant, because secant and cosecant have, U shapes, you remember? This is either tangent or cotangent. So let me show you another trick. But if you look at the graph, cosine, so whatever, if I plug in x is equal to 0, I will get 1. So which one is that? Cosecant, it's not cosecant or secant. Let's look at other options. Negative cotangent x. What is cotangent 0? Cotangent 0 is cosine 0 over sine 0. And sine 0 is 0, that's why we have 0 in the denominator, which is undefined. So this is not the case either. 2 secant x is not the case because it is either tangent or cotangent. Tangent x, but tangent 0 is 0, right? We should get 1. Okay, let's look at the last option. Tangent x, if you plug it in 0 over here, tangent of x plus pi over 4. If you plug in x is equal to 0, we will get tangent pi over 4, which is sine pi over 4 over cosine pi over 4. Sine pi over 4 and cosine pi over 4 are equal to 1 over root 2, right? They are equal to each other, so it gives 1. That's why the answer should be this one. And actually, if you, yeah, this is how you do it. You can just pick a point on the graph and plug it in the functions, whether it is satisfying or not. Or actually, if you look at the graph, it is just the graph of tangents, right? Shifted left, pi over 4 units to the left. That's why this is the answer, okay? So you can do it that way either. Let's check our answers. My tablet is kind of slow for some reason. Come on. Okay, correct. Let's go to the next one. Come on, you're too slow. Graph the trigonometric function, if I can see it. Start by drawing two consecutive asymptotes. Between these asymptotes, plot 3 points, a point where the graph intersects x-axis, a point to the left, and a point to the right. Okay, yeah, cotangent x, right? X minus pi over 4. First of all, where are the vertical asymptotes of cotangent? cotangent is sine over cosine over sine, right? So we have asymptote when sine is equal to 0. When is sine is equal to 0? Sine is equal to 0. Sine is equal to 0 for 0, right? Sine 0 is 0. So we have a vertical asymptote at 0, and we have a vertical asymptote at pi. But if you look at here, the phase shift is 3 pi over 4, so we are going to shift vertical asymptote pi over 4, 3 pi over 4 units to the right. That's why we have a vertical asymptote at 3 pi over 4 and pi plus 3 pi over 4. Okay. So, not over there. No, it is 3 pi over 4, so it should be somewhere in between. No. Ah, no, it's not even here. 3 pi over 4 is here. Come on. Yes. I have too many asymptotes. Let me raise those ones. Okay, nice. So 0 plus 3 pi over 4 is this point, right? 3 pi over 4. And the other one is pi plus 3 pi over 4, which is this guy. So we got two asymptotes. Now we have to plug the x-intercept, right? And whenever, so we have x-intercept when cotangent is equal to 0, right? So cotangent is again cosine over sine. So cosine over sine should be 0. But cosine over sine should be 0 means cosine is 0. And we know that cosine is 0 when x is equal to pi over 2, right? But we are shifting everything pi over 3 pi over 4 to units to the right. So, come on. Pi over 2 plus 3 pi over 4. So we have an x-intercept here, right? So, which makes 5 pi over 4. That's why we have x-intercept at 5 pi over 4, which is here. Okay. And we have to put another point to the left and to the right. And we know that cotangent pi over 4 is 1, right? Cotangent pi over 4 is 1, but we are going to shift pi over 4, 3 pi over 4 units to the right. But there is also, let me see, there's also 3, right? So there's also 3. So pi over 4 shifted to the 3 pi over 4 units to the right, we will get pi. So over the pi, it is 1. But we are also stretching everything 3 units up, right? So 1 should be 1 here. And similarly, there is another point here, right? Because cotangent 3 pi over 4 is negative 1. Shifted 3 pi over 4 units to the right. It will be 3 pi over 2. And negative 1 will be stretched to negative 3. Let's draw our graph. It is too slow. Yes. Let's check our answers. Come on, Alex, you are too slow. It's actually not because of Alexa, it's because of my tablet. Oh, unresponsive. Wait. Correct. Let's go to the next one. Find the exact value of tangent inverse of negative root 3/3, right? Okay. So this is a spatial angle, right? Which angle is that? This reminds us 30, 60, 90, right? And tangent is opposite over adjacent. So opposite should be root 3 and adjacent should be 3. So it is actually this one, right? This is 60. So this is 1 root 3 and 2. So 10, of course, this should be negative 1, right? This is negative y coordinates. So, and this angle is negative 30. So tangent negative 30. It's too slow. Equals negative, which is negative root 3/3, right? Yes. But our answer should be in terms of pi. So negative 30 times pi over, I cannot write it, come on, pi over 180, which will be, I can simplify 30 and 180, right? Negative pi over 6. Come on. Okay. I think I'm done. Let's find. Let's put the answers. Negative pi over 6. And don't forget the domain of tangent inverse is from negative pi over 2 to pi over 2, right? It is either fourth quadrant or first quadrant. It is slow again. Yes, correct. Okay, let's go to the next example. Find the exact value of sine inverse of sine 7 pi over 6. Okay, good question. I can simplify sine inverse and sine, right? Because they are inverse of each other. But we have to be careful, right? 7 pi over 6 is not in the domain of sine inverse. So domain of sine inverse is, again, first quadrant and fourth quadrant. So 7 pi over 6 is here, right? It is here. And if you think that the whole straight angle is pi. This part will be pi over 6. So this is our angle. We should get another angle in the first or fourth quadrant which has the same sine value. In other words, we should find another angle which gives the same y coordinate, right? Because sine is decided by the y coordinate. And to do so, just find the symmetry of this point through the y-axis. I know it's not writing well. Yes, let's take this angle. This angle, since it is symmetric, this will be pi over 6, right? But since we are going in a clockwise direction, it should be negative pi over 6, right? So yes, I can simplify them, but I have to find the correct angle in the domain. That's why the answer should be negative pi over 6. Let's try to put that answer. I know it will be slow. Negative pi over 6. Let's check the answers. So be careful which quadrant is the angle in. Answer cannot be 7 pi over 6 because this is it is not in the, sorry, I should say, I said domain, but I should say range. It's not in the range of the sine inverse. Okay, last question in this video. If it does not crash, I hope not crashes. Let's see. Okay, find the exact value of cosine inverse of 4 over 5. Another good question. Let me try to write down somewhere here. So remember the range of cosine inverse is the first or the second quadrant. And since this is positive, right? This is first quadrant. So tangent inverse of cosine 4 over 5. Sorry, I made a mistake. Making mistake is dangerous because it's too slow to fix it. Come on. Maybe I can write down again here. Tangent of cosine negative cosine inverse of 4 over 5. Remember from our lecture videos, or actually not from lecture videos, but from our previous lectures, cosine inverse is actually giving an angle, right? Cosine inverse is giving an angle. And we need to find tangent of that angle. And what do we know about that angle theta? Cosine is 4 over 5. So, and as I said, it is in the first quadrant because it's positive. This is theta. Cosine is adjacent over hypotenuse, so it is 4 and 5. And from Pythagorean theorem, we will get 3 over here. So this question is basically asking, if this is the case, what is tangent theta? And tangent theta is opposite over adjacent, right? So it is 3 over 4. It is that nice. Okay, let's try to find it. 3 over 4. Check. Okay. I'm pretty sure it is correct. So if it is correct, this is the end of this video. All right, so I finished working on the review problems from chapter 6. And there are also other review problems from chapter 7. But since I already have watched videos for chapter 7, I will not solve those problems. You can just go to the corresponding lecture videos and check how to solve those problems. Okay, I wanted to solve the first 20 problems because I don't have lecture videos from those chapters, to say chapter 5 and 6. Is it checking really? So by this video, I am, yeah, this is correct. By this video, I am finishing the final exam review videos, okay? All right, guys, I hope you liked it, you enjoyed it. Let me know if you have any questions.